Unseen mathematical proportions secretly dictate the spiral of a seashell and the branching of a tree. But this elegant natural blueprint hides a fierce scientific controversy, challenging everything you believe about nature's design. For centuries, thinkers have observed captivating patterns repeating throughout the natural world. From sunflowers to hurricanes, a specific numerical sequence, the Fibonacci series, appears consistently. Each number in this sequence is simply the sum of the two preceding it, starting with 0 and 1. Dividing consecutive Fibonacci numbers yields a value remarkably close to the enigmatic golden ratio, roughly 1:618. This particular ratio, often symbolized by the Greek letter phi, is proclaimed as nature's universal aesthetic principle. Advocates suggest its presence signifies a profound underlying order governing biological growth and cosmic structures. They point to the precise spirals of pinecones and the elegant arrangement of leaves on a stem. Discovering these intricate mathematical relationships feels like unlocking a secret language of the universe. But how deeply embedded are these patterns? And are we truly observing inherent design or just projecting human desires? This question sparks heated debate, dividing experts who either champion or dismiss its perceived omnipresence. Proponents passionately highlight the nautilus shell, whose chambers expand in a perfect logarithmic spiral. They argue this expansion precisely mirrors the golden spiral, a geometric shape derived directly from phi. You can also observe this fascinating pattern in the arrangement of seeds within a sunflower's vibrant head. The seeds form two sets of spirals winding in opposite directions, often counting as adjacent Fibonacci numbers. Imagine nature as a master architect, meticulously following these mathematical instructions for optimal efficiency and beauty. This precise phyllotaxis, the arrangement of leaves on a stem, minimizes shading and maximizes sunlight absorption. Many believe such intricate mathematical precision cannot merely be accidental, suggesting a deeper, guiding principle at play. Wait until you hear the counterarguments, which introduce a surprising twist to this seemingly perfect narrative. Critics, often mathematicians and statisticians, challenge the widespread claims, calling them examples of selective interpretation. They argue that identifying approximate golden ratios is frequently a result of observers imposing patterns onto noisy data. Think of seeing animal shapes in clouds. Our brains are wired to find order even where pure randomness exists. A common critique highlights the subjective nature of measurement, often manipulating data to fit the desired ratio. For instance, measuring a shell from different points can produce various ratios, not all magically close to 1:618. Furthermore, many natural growth patterns are governed by simpler physical laws, not necessarily complex mathematical constants. The optimal packing of seeds in a sunflower, for example, arises from basic geometric principles and spatial efficiency. It merely happens to approximate Fibonacci numbers because those are efficient ways to fill a circle. But that's not the strangest part. Some scientists even suggest a bias in the original measurements themselves. Early proponents, perhaps unconsciously, might have cherry-picked examples or rounded measurements to align with phi. They point out that many instances cited as exact golden ratios are actually approximations within a wide tolerance. What constitutes close enough to 1:618 often becomes a point of contention among rigorous scientific researchers. Some argue that if you look hard enough for any number, you will eventually find it appearing in nature. The universe contains countless numbers, so some coincidental alignments with famous mathematical constants are statistically probable. This perspective suggests that our fascination with the golden ratio is more psychological than empirically verifiable. It taps into our human desire for cosmic order and a beautiful, underlying harmony in the world. Yet, the debate deepens when considering how these patterns influence our perception of beauty and art itself. Many renowned artists and architects throughout history consciously incorporated the golden ratio into their masterpieces. From ancient Greek temples to Renaissance paintings, its presence was believed to create visually pleasing compositions. Is this an acknowledgement of nature's inherent beauty, or simply a self-fulfilling prophecy of human aesthetic preference? And then something unexpected happened. pushing the controversy into even more abstract and philosophical territory. Some researchers investigated whether animals themselves exhibit a preference for golden ratio proportions. The results remain inconclusive, often showing varied preferences across different species and experimental conditions. This suggests that, while humans might perceive beauty in phi, other creatures might operate on different visual metrics. The controversy extends beyond biology into physics, with some exploring its presence in quantum mechanics or cosmology. But these theoretical extensions are largely speculative and lack strong empirical evidence to support grand claims. The core argument remains: are we discovering an objective truth or projecting our subjective interpretations onto reality? This ongoing scientific battle has significant implications for how we understand natural systems and their complexities. If nature truly follows such precise mathematical rules, it hints at a deeper, almost deterministic universe. This perspective could inform new approaches in biomimicry, designing technologies inspired by nature's alleged perfect forms. Imagine architects creating structures with inherent strength and beauty, mimicking the golden ratio's theoretical efficiency. It could also influence our understanding of evolution, questioning whether these patterns are selected for or simply emergent. Conversely, if the golden ratio's prevalence is largely an illusion, then we must reevaluate our scientific rigor. This means challenging deeply held beliefs and scrutinizing evidence more critically, avoiding confirmation bias. It emphasizes the importance of robust statistical analysis over appealing anecdotal observations in scientific inquiry. The debate also impacts public understanding of science, highlighting how even celebrated concepts can face intense scrutiny. It teaches us about the fascinating interplay between mathematics, biology, aesthetics, and human psychology. Understanding this controversy prevents us from falling prey to pseudoscience and unsupported grand claims about nature. Instead, it encourages a more nuanced appreciation for the genuine complexities and true wonders of the natural world. The real beauty might lie not in perfect mathematical adherence, but in the chaotic, adaptive processes of life itself. This shift in perspective offers a profound intellectual payoff, moving beyond simple answers to embrace complex truths. It reminds us that scientific discovery is an iterative process, constantly refining our understanding of reality. The controversy serves as a valuable lesson in critical thinking, questioning assumptions, and seeking empirical validation. Ultimately, it pushes us to ask better questions about the intricate mechanisms shaping our diverse and dynamic planet. Whether a universal constant or a beautiful coincidence, the golden ratio compels us to look closer at everything. The compelling debate around nature's mathematical patterns reveals the ever-evolving frontier of scientific understanding. It challenges us to discern genuine phenomena from the captivating illusions our pattern-seeking minds create. Embrace the wonder of nature's true complexity, even when it defies our neatest mathematical expectations. If you found this exploration fascinating, subscribe for more incredible stories like this from the natural world. And let me know in the comments what other hidden patterns or scientific controversies truly intrigue you most.